Math 1343, Week 10, Video 4. When is the F distribution appropriate for ANOVA? Anytime you use a distribution for a confidence interval or a hypothesis test or something, there's always some sort of criteria that are necessary in order for that distribution to be appropriate. For example, when you're using the Z distribution or the T distribution for that matter, usually a sample size of 30 is good enough. And if your sample size isn't 30, but your population is approximately normal, you're okay. For the goodness of fit test and test for association, usually when your expected values are at least 5 in each cell. But for the F distribution, and its appropriateness for using it for an analysis of variance, there are 2 criteria you have to check. And they're pretty easy depending on what information you have at your disposal. The first thing you have to check is samples. And specifically, for each sample, there, sample size is at least 30. There's a shocker. Or, because sometimes you don't have control over your samples or it's not feasible to get a sample much larger than that, or the sample does not display any signs of not being normal. I like the number of negatives in that. So let's see if I can come up with a better way to describe that. In other words, any visual representation of the sample does not display outliers or skewedness. I spelled that completely wrong. Skewedness, so skewed left or skewed right. I'll show you an example of what I mean by that. And then we'll get to the second criteria. Not sure why there's a big gap there. If I can fix that. You're just going to be like that? Is that how you're going to act? We'll just forget the fact that I was trying to keep everything nice and lined up and let it be all justified to the left where I don't want it, but I guess there are worse things to worry about. So what do I mean by all this? Well, the sample size being at least 30 is pretty obvious. There's nothing really to explain there. But when I say the sample does not display any signs of not being normal, in other words, any visual representations of the sample does not display outliers or skewedness. Let's say we have a dot plot and it looks like this. Would you say these 6 dots really have any outlier or are skewed in any particular direction? Me neither. So this sample would be okay. But let's say you had a sample like this. Got some nice little normality things over here. Look, we're kind of all bell curvy in our nice little neck of the woods, and then we got a guy out here. This would not be okay. An outlier, or what seems to be an outlier because there's a numerical way to calculate one, but an outlier can really throw things off. So if your sample's not big enough and it contains an outlier, you wouldn't do this. Now don't worry, in my class, we're always going to be able to do the process because the way you would do this otherwise is beyond the scope of this course and involves calculus, and this is not a calculus-based statistics course. So that's criteria number 1. Sample size is at least 30, or the sample does not display any signs of not being normal. So no outliers, no skewedness, and that lack of a closed parentheses drive me crazy. Yeah. All right, so that's criteria number 1. So what's criteria number 2? Well, criteria number 2 has to do with the variability. The variability amongst the variabilities, I should say, among samples are not, quote, too different. What does that mean? That's supposed to all be about being definitive and clear and everything, and rigidly defined. What do you mean, not too different? Here's what it means, and not to knock statisticians, and statisticians are really good about, fluffy phrases like that. But there is a rigid definition of what we mean by the variabilities among samples are not too different. What that means is no samples standard deviation more than twice any other samples standard deviation. So it's okay if the standard deviations are different, but they can't be too different. You can't have one that's twice as big as another. So if you are being asked, are the conditions met to use the F distribution for an ANOVA test, you're being asked to check these two things. Let's take a look at the baseball data that we had from a previous video. Just a reminder, this data counts the number of hits obtained by each position in the batting order for each of the 30 teams in the 2019 regular Major League Baseball season. And over here we have all of the sample sizes and the standard deviations. Notice our sample sizes are good. They're 30. If our sample sizes were not big enough, we would look at a picture. And unfortunately, 3 of these did have outliers. One here, one here, one here. But because our sample size is large enough, that's not going to be a problem. Now, what about the standard deviations? Criteria on the standard deviations is none of them can be more than twice as big as another. Well, the easiest way to check that is to go for the largest and smallest standard deviations. So looking at these standard deviations, which one's the largest? Looks like in the 4th position, 19.09. Let's highlight that red. That's kind of hard to see. Let's highlight it orange. There we go. So there's the greatest standard deviation amongst our 9 sample standard deviations. The smallest one is over here. Now, is 19.06 at least 2 times the smallest one, 9.56? Well, if I just ask Excel, tell me this cell equals 9.56 times 2, and the answer is it is not. The largest sample standard deviation is not more than twice the smallest, barely. So there's no other standard deviation that could be more than twice another, because the largest is not more than twice the smallest. So these standard deviations meet the criteria, which means that we can and will use an F distribution to do an analysis of variance test. So a fairly short video, which is good to make up for the very long video at the beginning. But the variabilities among samples are not too different. No sample standard deviation is more than twice any other sample standard deviation. That, coupled with the fact that the sample sizes are all at least 30, means that we have the green light to use the F distribution for an analysis of variance on this particular